Hi folks, today we're going to talk about how to identify the x-intercept and the y-intercept of rational functions. Just a reminder that the x-intercept is at the location where you have an x value but the y value is 0. And y-intercept is the location where there's a y value but x equals 0. So that layout is going to help us understand how to find those intercepts. And that the intercept have should have an x value of 0. So, in order to find the x-intercept for a rational function, the first thing you want to do is simplify the function. So cancel out any factors that are common on the top and bottom. So simplify the function. That will get rid of any holes that you might have in the rational function. Then you want to set the simplified function equal to 0. So let's talk about what that means. In order for a function to equal 0, the function is f of x. And f of x means the same thing as y. So when you set the function equal to 0, you're really saying that the y value is 0. So you're substituting 0 for y, and then you're solving for the x value to figure out what x value you have for your x-intercept. So it's a basic situation of simplifying, making sure everything is canceled out that needs to be, but then giving 0 to the y. Now to find the y-intercept, you're doing the same thing but in reverse. You're replacing the x with 0 and solving for y. So in both situations, you substitute 0 for something and then solve for the other variable. So in number 1, I want to find the x and y intercepts of the following rational function. Well, if it's a rational function, I want you to keep in mind what makes a rational function or a fraction 0. Well, a fraction is 0 when the numerator is 0. For example, 0 over 3 equals 0. So it really doesn't matter what the denominator is, as long as it's not 0 as well, and that won't happen if we've simplified correctly. But we really just want our numerator to equal 0. We want it to be 0. So here, in order for me to set my function equal to 0, I want to set my numerator equal to 0. And I'm going to solve using inverse operations, and x equals 2 is the x value of my x-intercept. Now for the y-intercept, I want to separately replace x with 0 and solve. So if I'm finding f of 0, and I substitute 0 here and here, I have 0 minus 2 over 0 plus 2. 0 minus 2 is negative 2, 0 plus 2 is positive 2, and that simplifies to be negative 1. So negative 1 is my y value of the y-intercept. So that's how we find the x and y-intercepts of rational functions. Now, of course, this is more basic. They get a little more complicated, but it's nothing that we can't handle. So let's look at number 2. So factor and of x squared is x. The square root of 9 is 3, so there are my factors. My denominator also has a difference of squares, so the factors are x plus 2 and x minus 2. There are no common factors on top and bottom, so there are no holes. Maybe we should do this down here, but that's okay. We're going to set the numerator equal to 0. For that, we need to set each factor equal to 0. Well, 2 does not equal 0. That doesn't help. X plus 3 equal to 0 gives an x value of negative 3. And x minus 9 equals to 0 gives us an x value of positive 9. So my x-intercepts, I actually have 2 of them. One of them is where x is negative 3. And one of them is where x is 9. So now I'm going to solve for my y-intercept, y value. So I'm going to take 0, I'm going to substitute it for x here. F of 0 equals 2 times, you can either do it here, but I prefer to do it from the factored form. So 0 plus 3 times 0 minus 3 over 0 plus 2 times 0 minus 2. I have 2 times 3 times negative 3 over 2 times negative 2. So the 2's cancel out, the negatives cancel out. 3 times 3 is 9. The 2 remains on the bottom. So my y-intercept y value is 9/2. So we're just substituting 0 in and we're solving. We've got 2 more examples. In example 3, let's factor. The numerator is a difference of squares, so the factors are x plus 2 and x minus 2. The denominator is a trinomial, so 2 numbers that multiply to be 3 and add to be 4 are 3 and 1. So x plus 3, x plus 1. There's no common factors that cancel out, so there are no holes in this rational. I'm going to set the numerator equal to 0 so that I can find my x-intercept. So x plus 2 times x minus 2 equals 0. X plus 2 equals 0 gives an x value of negative 2. There's one x-intercept. X minus 2 equals 0 gives an x value of positive 2. There's another x-intercept. So I have 2 x-intercepts again. One of them is at negative 2, 0, and the other one is at positive 2, 0. Now, my y-intercept. I'm going to substitute 0 for x, so I'm finding f of 0 equals. I'm putting 0 everywhere I see an x. So I have on top 0 plus 2, 0 minus 2, 0 plus 3, 0 plus 1. This is 2 times negative 2 over 3 times 1. 2 times negative 2 is negative 4. 3 times 1 is 3. So negative 4/3 is my y-intercept. And finally, the last question. Let's factor. X minus 4 is the numerator, and it doesn't have to be factored. It's already linear. There's no exponents. The denominator is a difference of squares, x plus 4 and x minus 4. I notice that there's a common factor here. And that common factor means that there is a hole where x minus 4 equals 0. So keep that in mind. Now for the x-intercept, let's set the numerator equal to 0. Well, when I set 1 equal to 0, that doesn't really tell me anything, and it's not even true. So there is none. There is no x-intercept. Because when I set x value, so let's move on to the y-intercept. I'm going to substitute 0 for x. F of 0 equals, I'm going to use this function, 1 over 0 plus 4 is 1/4. So that's the y value of my y-intercept. So this gave us 4 examples and a brief description of how to calculate the x-intercept and the y-intercept of rational functions. In summary, you're substituting 0 in place of y to find the x-intercept, and you're substituting 0 in place of x to find the y-intercept.